Good afternoon, geometry students. We are in our last section of chapter 7. It's 7-5, and it's talking about proportions in triangles. Now, we've been talking all about proportions, and a proportion is just when two fractions are equal to each other, and we solve them by cross multiplying. This whole section has been all about ratio, similarity, and setting up proportions based off of properties that we know, and that's going to continue today. So what I'd like for you to be able to do by the end of today's video is to apply the side splitter theorem and the triangle angle bisector theorem to solve for missing values. So first of all, what is the side splitter theorem? It says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. In other words, it's saying the left bottom over the left right is going to be proportional to the right bottom over the right top. So that's all we're doing here. We're going to say bottom left over top left is equal to bottom right over top right. Now, if this were put in a different orientation, then it would still work the same, but I do want to make you be mindful that these lines must be parallel, so you need to have that symbol in there somewhere, and then we can set up these proportions. So let's go ahead and do that in example 1. In letter A, example 1, it says find the value of US. So what I want us to notice is we're going to say bottom right over bottom left, the bottom of the triangle, I mean. So I'm going to put 4 over 10 is equal to, then I'm going to do top right, or US, over top left, 14. So that's going to be US over 14. Now that I have my proportion, I cross multiply. So 4 times 14 is going to be 56 is equal to 10 US. I'm going to divide by 10 on both sides to isolate that US. And when I do that, I get 5.6 is equal to the segment US, which is this guy right here. All right, simple as that. In the next one, we are going to find the value of X. So I am going to put the top left over the bottom left, and then I'm going to put the top right over the bottom right. So I have X plus 4, top left, over 2X, which is bottom left. So left over left is equal to 9 over 12, or right over right. Remember, when we have proportions, the key is to keep it consistent. We could have written this a number of other ways, but I decided which direction I was going. I was going top over bottom and then top over bottom. So we need to keep that through the whole problem. Now that I have my proportion, let's cross multiply. So I have 12 times X plus 4 is equal to 9 times 2X. I need to distribute that 12. So I have 12X plus 48 is equal to 18X. And now I'm just solving any other equation. I got to get my variables on one side, so I'm subtracting 12X. And that leaves 48 is equal to 6X. Now to isolate that X the rest of the way, I want to divide by 6. And X is going to equal 8 for that final answer. Now we do have a corollary to the side splitter theorem, and it's very similar. It says if 3 parallel lines, notice 1, 2, 3, intersect 2 transversals, then the segments intercepted on the transversals are proportional. That's kind of wordy, but it's the same thing. I am going to say top left over bottom left is going to be proportional to top right over bottom right. So notice these are lining up and these are lining up. This will only work, though, if you have 3 parallel lines. So let's apply that here. In example 2, it says verify that DE is parallel to BC. So we want to show that this line is parallel to this line. It doesn't have a marker. But what we can say is, oh, if I'm going to have two things being proportionate, then I could then conclude, oh, those lines are parallel. So I'm going to line up 10 over 15 and 8 over 12. And I'm going to see if those are going to be proportionate to each other. So I'm putting 10 over 15 and I'm putting 8 over 12. I want to know, are they proportionate? Now there's two ways you can do this. You can write your two separate fractions and then reduce them. So 10 over 15 reduces to 2/3. And 8 over 12 also reduces to 2/3. So you can say, oh, they reduce to the same number. Yes. That must mean that these are proportional, which must mean the lines are parallel. Or you can just set them up in a proportion, cross multiply, and see if you get the same number. 10 times 12 is 120, and 8 times 15 is also 120. So because that balances, you could also say, oh, okay, the triangle is proportional. That must mean the lines are parallel. So I'm going to say DE is parallel to BC because, and then I'm going to say AD over DB is equal to AE over EC. In other words, I'm saying these two lines are parallel because left over right is proportional to left over right. And this is my final answer, saying why they're parallel. In example 3, we have a word problem. It says, an artist decided to make a sketch of trees in a park. In the figure, if AB is equal to 2.4 centimeters, BC is equal to 1.4 centimeters, CD is equal to 2.2 centimeters, and KL is equal to 2.6 centimeters, find LM and MN to the nearest tenth of an, we mean centimeters here, not inch, but centimeters. Okay, so we have, let me kind of highlight this a little bit because it's kind of tough to see. We have this line and this line, and then our parallel lines are actually kind of like the centers of the trees. Kind of like that. And we have these markings, so we know from K to L is 2.6. We know from A to B is 2.4. All of this here is marked in our image. We're trying to first figure out from L to M. So this length right here, what is L to M? Okay, we are going to set up a proportion by keeping it consistent. So I'm just going to say left, middle, and right for this. I'm going to put the left over the middle for the top line, and then I'm going to put the left over the middle for the bottom line, and that's going to set up our proportion. So left over middle, so that's going to be 2.4 over 1.4 is equal to left over middle, 2.6 over LM. When I do this, I need to cross multiply. So I am going to get 2.4 LM is equal to, and then 2.6 times 1.4 is about 3.64. Now I want to isolate the LM, so I'm going to divide by 2.4 on both sides, and I get LM is equal to 1.5. I'm just rounding because it told us to round to the nearest tenth. Okay, now I want to do the same thing, but now I want to figure out what MN is. So to figure out what MN is, now I'm going to do left over right on the top line is equal to left over right on the bottom line. Notice each time I'm matching up my proportions. I'm not going left, right, and then right, left. I'm saying the left part from A to B over the right part from C to D on the top line is going to be proportional to the left part on the bottom line over the right part on the bottom line. So that is 2.4 over 2.2. So that's left over right is equal to 2.6. Left over right over MN. Okay, we cross multiply. So I'm going to get 2.4 MN is equal to 5.72. Then I want to divide by 2.4 on both sides because I want to isolate the MN. So now I'm getting MN is equal to, now I put this in my calculator ahead of time. You would obviously need a calculator for this. MN is going to equal 2.4. That is rounded. I think it was like 2.38 or something like that. So there you have it for that part. Remember, just keep it consistent. Match up your corresponding parts. And that's going to be exactly the same for the triangle angle bisector theorem. It says, if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Basically, the left of the bottom over the right of the bottom is going to be proportional to the left side over the right side. So left over right is equal to left over right once again. Let's do a couple of examples with that. Now this problem is in a different orientation, but don't let that throw you off. I am going to once again say left over right. So that is 3.5 over x. So the left part of this side over the right part of this side. So now go back to the left side of your triangle. The left side is 5. So that's going to be equal to 5 over, and then the right side of this triangle is 12. That's the most challenging part of the problem. After you have that, you should be just fine with cross multiplying and solving. So cross multiply, we have 5x is equal to 42. Because 12 times 3.5 is 42. I cross multiplied to get that. I divide by 5 on both sides. And now I have x is equal to 8.4. All right, let's do it again. So I'm putting the left over the right. So that's going to be x minus 2 over x plus 5 is equal to, now, once again, left over right. So that is 32 over 40. Once you have your proportion, and a proportion is just when two ratios or two fractions are equal to each other, you want to cross multiply. Don't forget to put parentheses around these because a lot of times people forget to distribute. So this is going to be 40 times x minus 2 is equal to 32 times x plus 5. Now distribute, so that gets me 40x minus 80 is equal to 32x plus, and 32 times 5 is 160. Now I want to continue solving for x, so I need to get the x's together. I'm going to subtract 32x from both sides, and that gets me 8x minus 80 is equal to 160. Now I want to add 80 to both sides. I'm just working through and trying to isolate that x. So I have 8x is equal to 240. Finally, divide by 8 on both sides, and I'm going to get x is equal to 30 for that final answer. So that's all for today's notes. I hope that's making sense. The biggest thing I want you to take from this is to keep your proportions consistent. If you have questions, bring them to me in class, and have a good night.